I'm excited to present our next speaker. It's Oren Golan, former VP of Engineering at Sanguine, and he's going to give us an introduction to graph databases.
Hey guys. So I'm just going to talk to you about the journey that we went through at Sanguine Bio, startup in the medical industry in Sherman Oaks. And it's a journey of discovering a new world that really helped us and hopefully will help you. Or at least open your eyes to new opportunities and new possibilities of storing your data. Maybe I'll ask first to understand the audience, who here used any kind of a graph database, whether it's testing or production, it doesn't really matter. Maybe 10? 11. Not many of you, so that's a good talk for you guys. I have some pieces of code. I don't know if I'll have time for it because it's only 30 minutes, so we'll see how we roll. Also, there's time for Q&A at the end, but I think I prefer the questions right when I speak because it's more chaotic and crazy. So feel free to ask whatever and interrupt me and destroy my talk. I like it, so I have this kind of weird thing. So yeah. So everything that you see here is available on my website, all the slides. Feel free to tweet funny tweets, funny slides. And I like feedback, so shoot me an email, tell me that I suck, or whatever you think about my talk. Oh, yeah, so we have a swag for you guys. It's Mimikaki. If you guys don't know what Mimikaki is, you're going to have a surprise. It's awesome. So I have a few questions I'm going to ask them, and whoever will raise his hand first, we're going to get this awesome thing called Mimikaki. I just gave a talk a while ago. I said that Angular is dead. I had a video on YouTube. I didn't want to put it on YouTube. I didn't want to put it, like, publish it or tweet about this stuff. And my buddy told me, "Hey, Oren, your YouTube has like 20,000 views." And I'm like, "No way! I never tweet. Like, how come? Why don't you enable comments?" And I did. So I have a very thick skin. So yeah, shoot me an email with how I can make this talk better and how I can convey my message better. So, and you know, if you want to have thick skin, just go to a conference. It was an AngularJS meetup in LA. So give a talk in a meetup about the technology. Tell them that it's dead, and you're gonna get a lot of angry people. So that's the agenda. Basically, what's the use case for graph databases? How are they different than the traditional databases that most people know about? And then I'm going to tell you about a few databases that we explored during our the last year and a half. And then we're going to play with two of them, mainly the last one, hopefully. Anybody knows what's this guy in the middle? Any guess? Nobody knows? What's the most used or dependent library on Linux or Ubuntu?
Kernel?
libc6, I believe. Any kernel developers? So that's just one example of like what you can do with graphs and the values. Logistics, airplanes, Internet of Things. If you think about, you have a drone and you have your fridge and you have a bunch of hundreds of devices and they need to communicate between each other. Sometimes they should not communicate. So think about it as two nodes and an edge, and the edge can be whether they're authorized to communicate. If in the future your fridge will know that you're missing, you need more milk, the drone will come, deliver the milk. It needs communication between the milk and the refrigerator and the drone. Whenever the milk arrives, there's no more communication, so you can map it with edges and nodes in a graph. Fraud detection, there's a bunch of companies that are already using it, using graphs to detect abnormal activity that they want to alert you about. And in biology, right? So for cancer treatment and mapping the expansion of cancer cells in your body, for example, it's pretty good fit for graphs. And that's our brain. It's basically connected nodes, so it's a big giant graph. So let's talk about the advantages of graph databases. Anybody knows what's the name of this guy here on the right? Who said Finn? Dude, your lucky day. Can somebody give him Mimikaki? Can you help me? Thank you. It works both on a crusty or slimy. Nobody knows what I'm talking about. All right. You're crusty? Yeah, you're good. So basically, even though the name relational database had the word relational databases are not that great to map relationships. And it seems like graphs are naturally way better to map relationships, and I'll show you why in a few slides. Another advantage is whiteboard friendly. You can talk to the product team and just draw on a whiteboard your data store. And you can have good communication, and it's not like with tables, for example, like you show tables to your product guy and like, what the hell is going on there? Like, what are those foreign keys? Like, this kind of matching reality, and actually product team can draw it. You don't need to be technical, basically, to draw relationships. That's kind of one thing. That's, your typical SQL, if you have a lot of tables, it's like, what is going on here? I don't want to know. It's disgusting. That's not really funny joke. Don't take a picture of it, please. He's taking a picture of it. So I'm not going to say anything about this joke. Oh, that's a funny joke, I guess. You guys are a weird audience. What the hell is going on here? All the funny jokes are not funny, and this is just completely messed up. So performance. So if you think about social network, you want to hop between nodes or people, friend of a friend of a friend, 5 level, right? If you're going to do it with joins and MySQL or relational database, you're going to lose performance pretty radically, exponentially almost. And if you do it with graph database, it's like pretty much linear regression. You can try it on your laptops and you see it. Sometimes you just wait forever on a relational database. Flexibility. So, anybody knows who this guy is? What's his name?
Jake.
You already got one. Dude, nobody's watching this TV show, the cartoon?
Jake.
You have dirty stuff there, huh? Can you help me? Thank you. So I'll show you what I mean by flexibility. Crusty too? Anyway. So let's say you have this king that has a crush on this princess. Bubblegum, by the way. How do you map it with relational database? You're going to have a table, right? Yeah, makes sense. How would you do it with graph database? You have 2 nodes and an edge, and you put crush on. That's cool. Now your business change, right? And king likes another person. He has another crush. So you need to change your data structure, right? In a relational model, you're probably going to have another table. You're going to have the character ID. It can have 2 crushes, right? So it requires you to change your model. With graph, you just add another edge and then node, right? So it's really flexible. And think about more changes that you might have in your business that require many-to-many relationships. And now you need to introduce another table that will map them. So what I'm saying is that the cost and the time that you're going to spend because of business change is minimized using graph databases. That's basically... I wasn't sure if this is going to be funny, but yeah, you're an easy crowd to please. So there's this whole kind of tension between, it's not just dev and DBA, it can be QA and dev. And so I feel that at least from our experience, that you just let your developers kind of design the schema and become DBA. Some of them, one of the developers would discover that he really like databases, and he might be more kind of DBA person, but he's still going to be part of your team. So if you think about the whole lean manufacturing and Scrum and Agile, the whole idea of a team that can execute and complete the feature, it shows scientifically that it reduces the time it takes you to build features because you don't need to reach out to external team. So it's a good advantage that I believe for graphs. So what are the graphs out there? There's a ton of them. So I just focus on the kind of like 3 graphs that are, I think, the dominant players. That's from Wikipedia, pretty boring definition. A graph database is graph structures for semantic queries with nodes, edges, and properties that represent and store data. So those are the 3 that I want to briefly talk about. TitanDB, Kali, and Neo4j. By the way, is there any questions that you want to ask, or?
Any Microsoft Graph database?
I don't know of, but I'm sure that they have something, right? It's Microsoft. Anybody knows about Microsoft Graph database? No. Okay.
Is this open source?
They are all open source, different licenses, but yeah, they're all open source.
What about transactional data? How does that work with the concept of graph database?
Great question. It's very hard to do transactions, and I think that I believe that none of them have transactions actually. But I need. That's a which one?
Titan does.
Titan has transactions. I wonder if anybody knows about Neo4j? All right. Does Neo has transactions? Don't know. Okay, we should look at the docs. So that's Neo4j. I wrote down the first commit. It's the oldest one out of those three, written in Java. It's called a property graph. Property graph is a graph that you can have key values on the edges and also on the nodes, right? That's why it's called a property graph. Pluggable backend, I'll explain later on what it is, but basically Neo4j comes with its own database, data store. You can't change it. They have two kind of query languages, one called Gremlin, and one is a newer one they're trying to push called Cypher. Cypher is pretty cool. It looks like, maybe I'll show you guys. Hopefully I have internet. How much time do I have?
Probably about 15.
Okay, so it's kind of like an ASCII art thingy. So you can map everything with those kind of notation. There's a lot of stuff here, so that's the idea, and you can see it can look more complex. You need to get used to it. So that's yeah, that's and let's see Gremlin. Gremlin is a little bit different. So graph.traversal, that's another good. Here g.v basically will return all the vertices, all the nodes in the graph. I can say, hey, go to the out, all the arrows that goes outside or maybe inside. There's a ton of stuff here, but that's kind of like Gremlin. So just need to know for now that you have those two options. Most people, I think, use Cypher for Neo. That's the. What else is interesting here? License and price. Basically, Neo4j you can get for free the community edition, but it's only on one machine, one server. If you want to scale to multiple machine with some clustering and master slave, you need to pay for the enterprise edition. And there's a company behind it. There's a ton of pretty big community, and I like to use the TT time to first TT and whatever you say, time to first hello world. It's pretty fast to set it up, basically. That's Titan. There was a recent blog post by the CTO of Amazon. They're actually using Titan. I believe that for tracking what happened to a purchase that you make. Where is it exactly? There's like a big state machine and they want to know where it is, so they're using TitanDB. It's also in Java, it's also property graph. Notice that you have pluggable backends, so you can switch to Cassandra, you can switch recently to Amazon DynamoDB as the storage. It's kind of like the MySQL storage engine, a similar idea. So it's more flexible. It's a little bit harder than Neo to get around it or to understand it because the docs are a little bit weird. It's not as polished in terms of the documentation. It's Apache license, and there's a company that kind of like doing consulting and helping. Size of the community is medium, less than Neo4j. And this is my favorite actually, Kaylee. So this one is in Go, so it's just an executable. I don't know if you guys use Go, but it's compiled. So you can just throw executable on your server. It's very tiny. Some people are building it to work on your mobile phone with some bunch of frameworks that can let you use it as a local storage on your phone. It has multiple pluggable backends, so you can use LevelDB or BoldDB. It's very, very fast key value that is stored to the drive, but that's going to be local to your hard drive. So if your data is more than this, more than one hard drive, you want to scale it, you can use Postgres or Mongo. There's a PR that somebody sent a while ago for CockroachDB. There's a bunch of them. Also App Engine or the Google the Google has like on their cloud, they have like a cloud storage that I think that you can use. It's not going to be super performant, but I think it's possible. And it was created by a guy that used to work at a startup that was acquired by Google, and he worked on the knowledge graph at Google. So when you're using an Android and you say, hey, hey Google now, I want pizza delivered to Glendale, it's using some similar technology that Kaylee is using. So he took the idea and put it open source, and he changed the language from C++ to Go. So it's more approachable for engineers to help, because Go is fairly easier to learn.
Question.
Yeah.
For the pluggable backends, do they end up taking on the scalability of the backend or the consistency of the backend that you're using? So it just varies depending on the.
Exactly. So if you use Postgres, you can just put it on RDS, right, on Amazon or whatever, and then it's pretty much done. You don't even care about backups or scaling it. Amazon will take care of it for you. So it really depends on your need. Many people, what they're doing is they're using it for testing. They're using BoltDB because it's super fast, and it's an embedded database. It's embedded within the process. And then for anything production, they use RDS or Postgres. Yeah, it's pretty cool community. And actually, a few days ago, we just created a new website, and we, meaning the people that part of the community, and we have a new forum. It's discourse.kaylee.io, and an hour ago, actually, one of the lead, Barak, just posted an amazing kind of like overview of query languages for graph databases, and basically the different standards, SPARQL, and basically what influenced him to create the Kaylee query language, which is very, very similar to Gremlin, actually. That's a pretty good read. I didn't have time to read it because you just posted it like an hour ago. So, yeah.
One more question about the three players.
Yep.
Neo4j touts itself as having a unique physical data storage structure where the nodes are stored right next to each other, particularly on disk. And so with these other ones that have the pluggable backend, do they still have the same performance characteristics as VM? And how do they get around that technical problem?
Yeah, that's a good question. I would assume that there is some performance hit. I don't know how big and how crucial it is to your application. I would assume so, yeah. But I haven't tested it myself, but it's a good thing to do. I don't know if anybody did it, like a performance testing of those three. Yeah. All right. So I guess that's it for Kaylee. What I like about Kaylee, it's literally 1 minute to set it up, and I can maybe show you if we'll have time. Neo4j, let's show you briefly what's going on there. I gave a talk about something in Canada, and I wanted to look at the tweets, and people are moving from the US to Canada because of this guy, because the way he looks, and people are pissed in Canada because people are moving, so they're moving back to the US. So I wanted to map it into a graph. Let's see, that's a website for Neo4j. Okay, I guess I'm just going to skip it. I don't have time for the entire video, and all those videos are available on my slides. But that's how it looks like, right? So you can run pretty cool queries. I want to see everybody that lives in the US in love with Justin, that's the Prime Minister, and is moving to Canada, right? So you can do it with a Cypher or with the Gremlin query fairly easily. All right, Kaylee time. So if you remember, we had this scenario. So the way that Kaylee works, you have these files you can create, and it's called a quad file, and you can put in these file lines, and each line will create a node edge and another node for you. And it's basically, it's called a subject, a predicate, and an object. And what's important here is that this will be unique, the subject. So this, I wrote iSking, I'm using a character just for me to be human readable, and iSking, it can be a unique ID in your application. So your application needs to generate those unique IDs. Right now, Kaylee doesn't do it for you, so you just generate your UID, and then you can put whatever you want as a predicate, and then you can put here another node. Kaylee will know, if Kaylee will see this again, it will know it's the same node. So you don't need to tell him that it's a new node, it just knows it. So that's how you define those relationship with those quad files. That's an example of a query. So the first piece, the g.v and then character king, is kind of like where to start your search from. And this is important because you don't want to search, if you have billions of nodes, you don't want to search from the entire database, right? So in this case, I'm saying start from this guy, from this node, the character ice king, and then I want to say do the traversal. So in this case, I'm doing out all the edges that go outside of this guy, basically, that has crush on. And the result is those guys. Maybe there's another one. Anybody that has a crush on bubblegum. So see, now I'm using the in, right? So I'm starting from Priest bubblegum and any arrow that goes to her, and the result is ice king. You can't see anything here, but that's the entire kind of like database I created. It's called db.enqueue. It's a file, and that's the command to load it into the graph. Maybe I'll show you quickly. So, see here, I have this file. That's the config file. You can define what your storage engine is. In this case, I want to use BoltDB, just because it's fast. And that's a database. It's a single file for BoltDB. And you're responsible for actually doing the backups for Bolt. Right now, it's not part of Kali. So you need to make sure that you don't lose your data if your server is down. Now, the command to initialize it is init. As soon as I do this, you will see that I have this file here called venturetime.db, right? And now I'm going to load my data. Actually, let's show the load command. Okay, I just loaded the data. And I want to show you the quad file, okay? So you can see here that the first piece, right, is each one is a quad, right? So I have Finn, he's type human, right? And I'm using type because unlike Neo4j, you don't have properties. You can't define key values on the nodes or the edges. So if I want to find all the humans, right, I need to have this extra quad. So everything is, it's kind of very, very simple, very basic. It's like building blocks, but it's also very flexible. And then you can define all the characters and all the relationships between them. So let's just run it. I have two options. I can use the REPL or the HTTP interface. So I'm going to run it with the HTTP interface, which is this guy. And it's running on this port. Let's open it. Already open, actually. If I go here. Okay, this is the query that I'm going to run. Actually, it's like a JavaScript-like environment. It's some library in Go that kind of like give you like a JavaScript VM, some sort of, and you can have like, in this case, a variable, right? So I want to get all the headers that live with BMO, it's one of the characters, together, basically. So it's an intersection, right? So I'm running it, and I'm getting Finn and Jake. There's also query shape. It's not very nice, but we're trying to make it use React now to change the UI and maybe use some visualization tools. It's pretty ugly right now. It gives you something here. You can kind of move it around. I'm not sure why would you want to do it. But it's basically this guy here. Find all the headers that lives with BMO. If you can see. So that's what we did. So it's pretty flexible, it's pretty cool. There's a few features that are coming to move on. So in the pipeline, like in the next few weeks, one is the type quad values. So right now it's all strings, but it would be nice to have like integer and date and stuff. So we're adding this stuff. Updating nodes. So right now you have to append everything and delete nodes yourself. So update will be also added. Aggregation, instead of you doing using JavaScript to insert into variables and do aggregation on the application side, you will be able to do it within Kali itself. And partial matching is what you know from MySQL or SQL, like, and maybe even regex kind of search. So that's coming in the next, hopefully, few weeks. I display with it, and it was fairly easy. Because it's so small, the footprint for Kali, you can just put it on tiny devices like Raspberry Pi, and if you want. That's a demo. I'm not going to play it now. If you want to learn more, there's a new website. There has nothing on it right now, but it's a work in progress. No, literally, there's nothing there. And so disgusting. No need to show you. You saw the forum already. IRC, it's free node. Sorry, we're not using Slack because reasons. GitHub, it was actually part of Google because he was a Google guy. So up until a week ago, it was under Google, but the license was weird. If you want to contribute, you had to like sign a weird Google agreement. We were able to pull it out of Google, so now it get a lot of traction in the last few weeks because people contributing. So it's a good product to be part of. Bunch of videos. That's it. Cool. I have 4 minutes.
Yeah, you want any questions?
Yeah, there's 4 minutes to questions. Yeah.
What are the disadvantages of graph databases?
Disadvantages. First is that it's not as popular, so you need to do a lot of research yourself to find the answers, right? So in terms of popularity, Neo4j is your best bet. It's the most popular one, the most well documented, but you have the cost that you need to think of when you use it. Other than this, just it's not very well known. The query can be a little bit challenging at the beginning. Yeah.
2 questions. First, is there a tool to port the tabular relational to graph?
Okay, so the question was if there's a tool to convert tabular into graph. I'm not aware of one, but I don't know.
Okay.
Good question.
Second question is there a way to have multiple connections from one point to the other? Let's say you hate me today, and you love me tomorrow. Is there a way to...
I know people like that.
So the question is that what if I hate, what's your name?
Jason.
I hate Jason today, but
Impossible.
No way. But tomorrow I might love him, right?
Yeah.
So I mean, it's up to you. You need to add some dates to your it can have like you can have a node, right? That is in between basically, and you can have like a hate. Or a date to the hate and then date to the love node. I mean, it really depends on how you structure it, But you need to introduce more nodes and more edges to reflect it and have the dates on them. Yeah. Any other questions? We have 1 minute. I think we're good.
All right.
Thanks. Thank you. Good stuff.
Thanks. That was really good.
Hey Nick, I love your dog, man.
Yeah.
This is awesome.
Yeah.
Hey buddy, Coco. Ooh, you like me too.
On the phone.
Oh my God.
Are you gonna be around or?
Yeah.